Hello everyone, welcome to suMON problem solving video. Today we are going to solve a puzzle type problem wherein we are going to move numbered blocks from 3 to 1 arranged in a vertical way to 1, 2, 3 arranged in a vertical way. Now you have two spaces in the horizontal way, so you have to cleverly rearrange them and convert it to 1, 2, 3 in the minimum possible number of moves. Let's get started and keep solving. Here is the statement. You have a puzzle to slide around the blocks around a box until the numbers read 1, 2, 3 as you go down. Here is the box and block arrangement. How many moves do you need in an optimal way and how do you perform it? So now is the time you can pause the video and think about this question before we get started. Maybe you can take 5 minutes at least to try this. Okay, say we start from the original configuration. The very first move should be done with a proper conscious effort. You have to move 1 to the top and 3 to the bottom. So either you can move 2 and 3 to the right and left spaces and shift 1 to the top, or you can move 2 and 1 to the left and right spaces and shift 3 to the bottom. Either way, you achieve the positions for the extremas, then you can move the other extrema, then bring down the 2 beneath the top so that it's in the middle. This is our algorithm. Now if you frame the algorithm, everything comes as a consequence. So with that in mind, let's say bringing 3 to the bottom is our aim. So we first move 2 because that's the only possible way. No other block is mobile. So 2 is here, 3 is here, 1 is here. And now I'm going to shift 1 here and afterwards to the right, because I'm now paving pathway for 3 to move to the bottom. So this will constitute 2 moves additionally. So therefore I get the following configuration: 3 here, 2 here and 1 here. So here we have 1 move, here we have 2 moves. Let's write 1 move here. Alright, time to take 3 to the bottom. After shifting, we get 2 moves to perform it, because 3 to the middle and then to the bottom. Therefore, I have 3 at the bottom now, 2 and 1. Now my goal is to shift 1 to the top and then 2 in the middle. In order to perform that, 1 should be placed in its left and then move to its top. So that comprises of moves horizontally left and vertically up. So this gives us 2 additional moves and therefore I get 2 here, 3 here and 1 here. Next, just 1 move to take 2 to the middle position and we arrive at our required configuration. So here the fundamental idea is the same. Either you bring 3 to the bottom or 1 to the top and then place the 2. Because if you are going to place the 2 otherwise, that will block the pathways for 3 and 1 to move to their respective extremas. So I chose to move 3 to the bottom and later on 1 should be moved again, because moving 2 will just block the pathway, right? Because that's the only square which connects all 4. So in order to make a pathway for 1, I kept 2 as such and moved 1. And then we shifted 2 to the middle, and this is the systematic way of approaching the optimal number of moves, as the fundamental does not change for any other sequence of moves. So therefore, I claim that 1 plus 2 plus 2 plus 2 plus 1, that is 8 number of moves, is the minimal possible. That is 1 plus 2 taken thrice and then a 1 gives us 8 moves. If you consider any other possibility, you have to first think about the fundamentals underlying in your algorithm and then make the pathway accordingly. But that is going not to be less than 8, because each of these tasks require at least 2 or 3 moves as we did. Alright, so this is how we design the problems for kids. So this problem is particularly directed at kids of grade 3 and 4. So even grades higher can attempt this, but these kids generally get intrigued by these kind of ideas and optimal searching configurations. So you can join us if you would also want to participate in such questions and involve in critical thinking. Let's meet in another video to discuss further. Thank you everyone. Bye.